So just the topic today is like generative AI, MLOps, and all that jazz. And I'm sure that all of us have been countenance to uh, the big talk in the town that AI has become hot again, and particularly every other day you find some great announcement in the generative AI space, and papers are coming thick and fast, and also we are seeing a lot of like a flurry of jobs that are coming in. And so I think in this landscape, it's important to understand where we are and how we can place ourselves to take advantage of this scenario and how we can uh, contribute maximally, as well as gain much in the process. So before that, let me give you a quick background of who I am. So my name is Parivesh, and I majored in physics and applied math from Columbia. After that, I worked for a few years as a trading quant at JP Morgan, UBS, and a few hedge funds. And I've also worked, I work at Amazon as an applied scientist, and particularly in the search division. Here, I have worked on three things primarily. One is spelling correction, autocomplete, and visual search. All of these things are live, and every day we interact with these. Um, so I will give you a quick rundown of why these things are hot and some of this. So for example, one thing is that taking a cue from Victor Hugo. I mean, no power on earth can stop an idea whose time has come. And it seems that a confluence of factors are leading to like this big revolution. Of course, Transformers came way around 2017, and Transformers were parallelizable. So the only thing that was missing was that how could you train these transformers on internet scale data? So for that, computing had to catch up, right? So Nvidia and ARM and all these, like every each year they come up with like better and better accelerated computing, right? When it comes to the GPU architecture and the communication links and everything. So we see that there have been a lot of algorithmic advances. Also, transformers have been amplified in terms of like how big they are, the number of parameters of the models, and we can train them on in a distributed manner, leveraging a lot of GPUs on multiple nodes. So, and also we are seeing that a lot of problems before were handled in a kind of an archaic way, a lot of like rule of the thumb way, and but imaginative ways of doing something were not tried much purely because AI was not there. AI is still not like a solved problem, but we have come a long way in many areas, particularly in text. So vision was a sufficiently well studied problem in AI. So back in 2012 itself, ImageNet competition use people saw that AI models really beat everything else hands down. And from that point on, right, like models kept getting better and better in vision, but text was not somehow catching up before 2017 came and Transformers came along. There were advances, but um, the ability of the model to like really take a very long, let's say, paragraph or a context and link things which are far apart semantically, right? Those kind of capabilities were not there, and it was very intensive and slow. So therefore, generative AI has become very hot. And when someone says generative AI, the idea core is that some input is going in, and some the model is kind of like generating something, right? So think of it like, and everyone, each of us has had an experience in, let's say, GPT, using GPT-4 and GPT 3.5 and what have you, Bard, and the prompt is the input essentially. And think of the AI piece as a black box, and it tries to give an answer to your prompt, right? And now you can totally start to think about multimodal models and all whatnot, where the inputs could literally be not just text, but it could be an image, it could be a combination of multiple cues, text and image. And now I think we recently, just 1 or 2 days ago, Gemini came up with like a multimodal model. Sorry, OpenAI came up with a multimodal model which can generate videos from text, right? So we had DALI, which would take text and generate an image. You see that some of very imaginative models have started doing a lot of very interesting things, and now people are trying to like retrofit these models and see what kind of things they can automate that in a smart manner, right? So of course, GPUs and model advances, and now, like I said, right, several products are being rethought, and new use cases are that were considered outlandish before are now being tried. And so it seems that for a lot of companies, AI is not just a good to have. It in many verticals, it actually has become a must have, right? So an example from, let's say, Amazon would be that previously when people used to induct their products into the catalog, they will write like um, their own product titles and all the metadata for the product, so that when you search, you will get something bubbling up. But you can totally see that a human being doesn't have a full intelligence of what kind of phrases might be more compelling. The grammar might not be there, their diction might not be very attractive, right? So then can generative AI, let's say, write better product descriptions? So that's one use case. There are several such use cases. And search is a very popular thing, right? Where people want to search more meaningfully. People want to search more complex things. You could have like an image, and you want to ask things about that image. You could have several such use cases. And of course, you this has led to, let's say, the number of jobs in AI going up, and salaries have also shot up. And um, just a few days, like maybe 4 or 5 months ago, there was a news article about Netflix, literally giving 900K for one AI product manager. Now, that might, of course, be, let's say, an outlier, right? Like, it's not everyone is getting 900K, but the idea is that if you're really good in AI, and if you can enable AI to be embedded into products that are literally out there in the wild, then you are very useful, and money follows likewise. But again, in this gold rush, the best people are still very hard to find. So of course, when there's a gold rush, everyone with a shovel goes and tries to dig things, and that's why a lot of people are trying to like get into this field in different capacities, and but companies are still struggling to like hire the best people. And the reason is that this the overall profiles need a combination of many skills. So it's not just coding, for example, or not just knowing cloud, or it might not just entail knowing data engineering. It might also it might very likely need like an amalgamation of various competencies. And that's why I think a lot of like that's why there is a need to combine many skills, and preparedness of to excel in these job interviews also need to be kind of streamlined. But it doesn't end there. Also, when you land at your work, you will need to like for example, have some proficiency in reading papers very deeply, quickly understanding them, maybe integrating them, trying them out, right? So it is a kind of like a far cry, so to speak, from just the traditional lead coding and like grunting code day in day out, right? So some cookie cutter techniques, right, are not out of the window. So coding is still a component, by the way, but other features have been added to the overall interview experience. And like I said, right, like formulaic approaches, like let's say cramming lead code, like are insufficient. So they are necessary, but they are not sufficient, right? So that is why this there is probably a need for understanding, right, what kind of extra things, what kind of other bells and whistles I need to add to my set of competencies, so that I have a best chance or likelihood of like excelling in these different things, and gravitating towards what I want to do in the AI space. Um, so let's try to by the way, if you, I'll definitely be like, watchful of any questions. So I'll take questions as they come. I don't want this to be a monologue. But I would like, if you have any questions in your stream of consciousness as I'm going through this material, please feel free to ask. Anyway, so let me try to deconstruct GenAI a little bit. Okay, so the idea is not to like overwhelm everyone with like a lot of math. Um, so, but I'll try to still unpeel some layers. So, for example, some of the things that you must have noticed if you even casually pour over LinkedIn posts and everything is like the pace at which research is moving is overwhelming. It's very fast. Great research is coming. So there's a need to kind of categorize these different things that are coming at very fast at you into different buckets and understand which papers to prioritize, what to read, what knowledge to like really bolster, what knowledge to like keep at the back of your mind, and then retrieve if need be, get better at if need be. Um, so then the question is how to keep up with the latest and greatest, right? So of course, if you want to read Shakespeare, if you want to read the greatest prose writers and poem writers, right? You better like have a litany of things that you have done to get there so that you can actually exercise your discretion in what to read, what not to read, right? So I think we need to definitely work towards like having a decent familiarity with the parlance, and parlance here means a decent facility with math, a very good intuition about AI and use cases, and reading papers, right? There are different disciplines that we have to reinforce. And the IK experience is actually designed and geared towards like kindling some of those interests in you. And myself and many other people who are already a research scientists and applied scientists at these different companies, we tailor this curriculum to make sure that you guys are better placed there, and you guys can think through the interview's hat and preemptively like prepare, looking at a job description, for example. And then the question is that how to quickly like kind of adapt to this changing landscape. So people amongst you, right, they might be traditional software engineers, people might maybe doing some different kind of AI, and they might want to like really speed up in the Gen AI space, um, or understand how to be more hands-on and not just like build a model offline and then wait for other people to deploy it, right? So there's a lot of things that happen from let's say taking a very nebulous idea that maybe a business leader or business stakeholder has, and then taking that and kind of like chiseling it into something that you can attack through model, and literally after that taking it to production, right, and seeing how it is behaving in the real world. There are a lot of hoops that you have to go through and understand, and that when you do that, then you understand, right, where you can contribute value, where you think you do not know enough, where you can read papers, where you can supplement it with decent knowledge. So I feel that having a full idea of the assembly line of like how an idea goes from just being an idea to to a solution that actually tries to solve a problem in the real world, and how do we know, okay, whether the solution is good, what can I do to make the solution better, right, and how can I iteratively continue being good, and how is, let's say, an AI system different than traditional APIs, right, traditional code driven servers. So those aspects are very important. So of course, a natural question could be, okay, let's say with my current skills, where can I be most useful, right? And given this, and let's say if you have a full idea of the assembly line, then there will be some portions that will appeal to you more, right? And you probably could have a better kind of deliberation and a consultation with IK, for example, to understand, okay, I am here and these things come very naturally to me, but how can I move here, for example, right? So that navigation can be made much easier. And one important thing again is where to begin, right? Like, is there some method behind this madness, right? So this is second, I just missed a word, my bad. Yeah. So understanding, like, is there a way to like just go through this clutter and kind of organize some information. So we aspire and we work very hard to make sure that we shed a lot of light on these kind of things that really appeared in our own journeys, right? So we are very empathetic when it comes to like the challenges our learners feel, because each of us has been a learner and we are still a learner, right? So we have grappled with these things in the past, and we continue like thinking about, each of us has our own mechanism, and a lot of times we exchange notes and we come to the common consensus. So we have grappled through some of these ourselves. So I believe that we have that empathy in us to understand where the shoe pinches. um, so coming to the next thing. So Here I will I'll just try to like give a little bit of flavor about generative AI in general. So one thing you will learn is that there are typically 3-4 phases. One phase is pre-train, and the idea here is in a nutshell is like you train very large models. And when I say large, you can actually quantify models by large. When you say large, it in generally it means like it has a lot of parameters, meaning it has a lot of knobs you can tune. And but it doesn't end there. So these models could be so big that they do not fit on, let's say, a single GPU. They might not even fit on a single node, for example, right? And then you are training it not just on a small data set. You might be training it on really internet scale data, right? So much so that training these models typically might take many months, actually. So there are some players in this space, as you might know, right? Like Google, and or a lot of open source also is there. But idea is that these models have like a decent world knowledge, right? So they know about a lot of things, but they might not be an expert at, let's say, if you want to do that particular model to really do well. Let's say you work in legal and you want it to really answer a lot of questions on your own legal documents, right? So then this means that these we want to leverage the world knowledge, but we also want to kind of like fine tune it on our own domain, right? We want to adapt it to our domain. So typically the second stage is like fine tuning. So once you have a pre-trained model, you like to fine tune it, or this is also sometimes called domain adaptation. So you like to take the pre-trained models, right, and you want to adapt it to specific domains. And typically this process entails taking the pre-trained weights and then running your data through it, and such that these weights kind of like get perturbed to also do well on your own, on your domain, without relinquishing what they have learned in the pre-train. That's It's a challenging problem. How do you fine tune it without forgetting what you have done, become good at already, right? So there are many techniques to do that. So we also teach you how to, for example, fine tune and domain adapt. Of course, we give you all the math, all the details that are needed to understand what pre-training actually entails, what are the challenges, how to do distributed training. So all these pieces completely we shed light on, and we give you we run through papers, we give you a list of papers, a lot of these things. Final thing is, right, it's still not there. So typically what happens is, remember, generative AI always is like takes X, takes an input, gives an answer. But that answer might not be agreeable. That answer might be stale, right? Because Trinita, all the model was trained on some data that was in the past. But you could be asking a question that is very like from the now, right? So there could always be, or maybe the model, the training data had like a little bias. Maybe it was trained on a lot of like abusive stuff or something, right? So some biases might have crept in that case, right? Just regurgitating an answer is not enough. You also want to make sure that it is aligned with like human preferences, right? So there is this, typically there's a third piece that is there, and this was the piece that OpenAI and these other people championed. So A and B, pre-train and fine-tune, were already there before things became very famous. But the problem was these models were not being taken to real world, because people were apprehensive of what if the answer that it spits out, right, is abusive, or is toxic, is using toxic language and whatnot, right? For example, if you ask an LLM to make a bomb, like how to make a bomb, let's say if the training data, there is some training data that tells you that. What if you want to quench those or suppress those answers, let's say. Right. So this third piece is where techniques like RLHF, which is reinforcement learning through human feedback, or DPO, direct preference optimization, right? There are some other myriad techniques that can be used to align these fine-tuned models to human preferences. So typically these are and within each of these three verticals, you could have many papers, right? So this is at least the overarching three things that you definitely want to like categorize your paper reading on. But even that doesn't tell you everything, right? So then other pieces that we typically go through in our classes is, for example, what goes in, right? What kind of important things you have to keep in mind when you're prepping the data for sending through the large models, right? So for example, if your data has a lot of, like, let's say, duplicates, it will pick up very spurious language capabilities, right? So this means that there is a chance for there is a place for let's say like making sure that you do not have a lot of duplicate passages, for example. There could be a use case where, let's say, right, you typically train your model and you evaluate it on a data that the model has never seen. But because these data sets are so large, there could always be some sort of like a impurity, some kind of a leakage. Meaning there could be a use cases where the data that it was supposed to be evaluated on is also a part of your training data. So then we need people who are able to like make sure that there is no leakage as such. So there are many small things you have to take care of when you're doing data preparation, for example, right? And this has scale, right? So this means that right away you could think of, let's say, like a data engineer being able to write a user defined function on Spark that could do this, or streaming data is coming and you could write, like you could see people, those kind of people being useful here, for example. But this is just one part of the story. You want to take that data and pass it through like models that somehow, some more often than not, they do not fit on one single GPU, right? Or one node. Then how do you do distributed training? So typically the scenario would be there will be multiple nodes. Each of those nodes will have multiple GPUs, and the entire model will be split on them, right? And then we'll be sending data in chunks to each of these, and then things will be communicating with each other. Eventually, when the training is done, the weights will be what they need to be for the whole model. Right? Of course, this looks like haiku, but we showcase, like, for example, different parallelism techniques like data parallelism, tensor parallelism, pipeline parallelism. There are many techniques that we have to think through to be able to even understand what distributed training entails. And then even that is not the end of the story, because these models are so large. The next question is, what if, let's say, I have trained a model, that model really takes a lot of time to give an answer back, right? Remember, right? More often than not, these API calls have timeouts, right? You do not want people to be chewing their nails while waiting for an answer to come back. So this means there are very tight latency constraints, bandwidth constraints, and all these kind of things, right? So then the question is, how do you take this large model and, let's say, reduce its memory footprint, reduce its size without losing a lot on the effectiveness of that model, right? So there are a bunch of things that we have to learn to optimize us inference, right? So this typically, this kind of thing is called inference optimization, right? So there is a whole lot of things that we cover to talk about, how do we make sure that one single latency, right? One single latency is optimized, right? And then let's say all said and done, right? There is a beautiful model that you have deployed, but that doesn't mean that, but you still have to do a lot of things. Like, how is the model performing in the real world? How can we quickly calibrate? If it's really going downhill, can I revert to an older model? How do I make sure that my model stays relevant? What should be the frequency of retraining? Like all these other things, right? Bells and whistles. So this means that we need to continue keeping our models refreshed and factual, for example. Right? So there are laundry list of things that people need to do to make sure that we can monitor health, what kind of KPIs we should have, how can we log metrics, how can we log user impressions that kind of somehow give me a signal of user engagement that is happening because of my model, right? Stuff like that. So you can totally see that, there is a space for a lot of like contribution on different areas from people of different skills, right? Any questions? I'll wait here just to see if you guys have any questions. Um, Anyone? Feel free to raise your hand. Do not be shy.
Parivesh, there are a few questions in the Q&A box. I think we can answer them as well. And guys,
One.
if you have any question, please raise your hands. We will unmute you and then you can ask your question directly to Parivesh.
Okay. Yeah, Anthony. Good. Yes. So there are a lot of jobs. The problem is there are also a lot of applicants because a lot of like, people were let go, right? So the reason you might not be getting a response is could be that, it has become competitive also because of a lot of people applicants. Also, like you said, right? Yes, there have been a lot of jobs, but those jobs have become rarefied purely because they're coming from, let's say, Amazon or Google or something, right? So a lot of people are clamoring for it. Having said that, job like preparation typically takes like whatever amount of time, right? So you could play like a long and patient game to give your best shot at whenever that time is. So yes, it's like a host of factors are there right now. And to be honest, like during the COVID, a lot of overhiring happened because business was doing great and people were staying home and they were like, and so I think there was a lot of oversubscription. Um, but within firms, I can totally tell you that, the precedence that is given, right, is mostly to AI products right now, right? If you do not have a AI roadmap, AI in your roadmap, then people are really apprehensive. Like, there is no top support in general. um, so yeah, I think the long-term strategy will be to like really bridge that gap, and be where we can when the time is right. And yeah, so that's the thing. Let me look at what are okay, yeah. Someone asked what are these professional called as? So I will come to the different profiles towards the very end. So I have that piece. I will definitely address that question. Um, Correct. So that is why Richard, Richard, you are saying the hardest problem with AI at my previous company, how to use it if you cannot train a public AI using internal data. So yeah, that's the whole thing, right? You can take a pre-trained model and you can fine tune it on your own data, right? So for example, Mistral releases release its weights and everything for you to be able to like fine tune it. But you're right. Some of the, for example, OpenAI will did not release their weights. So the only thing you can do is inferencing. You can only get their answers. But there are some open source models that are really good that you can take and fine tune for your use case, for your on your own data. So this is not like fine tuning is not globally true. Fine tuning can be done for in any case where pre-trained weights are known to you and are given to you. I will again, another question is what skills would product managers need to learn to get an AI product job? So I will come to all of these questions around profiles towards the very end, and I'll really answer all of these in detail towards the end. Yes, we do teach fine tuning and domain adaptation. So we give problems, we teach the underlying theory in great detail, actually. And then we have a paper review, and we have problems to make sure that you have practice. Of course, you can totally see that we will not teach you pre-training, like let's say a 70 billion model, right? For obvious reasons, it takes months and months. It is not feasible, but we give you all the theory that is needed to understand it. And but the fine tuning, we can take a smaller model, and we do teach fine tuning actually, but on a smaller representative pre-trained model. Yes, but we do teach underlying math and everything. And we also have paper reviews as a part of Gen AI, and also other modules are there that teach that. Yes, Anthony, that's true. We teach hosting. Yeah, so we do teach things, and I will come to it. But we do teach, for example, containerization and like how to make these scalable if the application is cloud native. So we do teach Kubernetes, for example, right? So we do. So I think our idea is to tell you, like like demystify why these components are needed and give you sufficient details for these things. Yes, so we do teach these things where they fit. Yep. Um, when do you recommend RAG versus fine tuning? Okay. So typically, RAG, right, is used in use cases where, let's say you just want to do, like, through your question, you want to answer everything. So for example, if you feel that the pre-trained model must have seen the kind of data, enough data from your domain. Let's say you know that, right? So in that case, if you have a bunch of your own documents that you have indexed, then you can amplify, you can take your query and you can do a RAG. And then now your context is your own query and the retrieved documents. And now the pre-trained model, right, will be able to navigate its space and give you a decent answer. This works really well if your pre-trained model might have seen a lot of your domain data. It's just that it is so big that it's hard to discover those pathways for a good answer to come out. In that case, RAG helps in better generation, right? So RAG typically follows something called conditional generation, right? So conditional generation, all it means is you take your actual prompt, based on that prompt, your query, you get a bunch of documents. Now you form a new prompt and you answer questions based on this new prompt, which is your previous prompt plus retrieved knowledge, top documents. So yes, we do teach these things. I think you will have better answer to these questions to do that. Yeah.
Sorry, Parivesh, sorry to cut in between. There are
Yeah.
two people who have raised their hands, so I'm unmuting them. Let's take
Okay,
questions
sure.
from them.
Go ahead, please. Yeah, Srinivas.
Srinivas, I have unmuted you. Can you go ahead and ask your question?
Hello, can you hear me?
Yep,
Yes,
please.
yes.
Yeah, my question is so basically, I'm an engineering manager at SAP.
Mm-hmm.
So we are doing some AI solution, but thing is there any language specific constraints to implement AI in a large scale applications? Like, can it be done with Java specific programming frameworks, or any only Python or something? Is there any idea like
Sure.
how these models are
Yeah, yeah, yeah.
defined? Yeah.
Sure, sure. Yeah, I can give you some flavor. So typically, the models which are trained, right?
Mhm.
The frameworks, right? TensorFlow and, for example, PyTorch, right? So
Mhm.
they give you abstractions. They give you so PyTorch definitely, as name suggests, uses Python. Type
Right.
TensorFlow also has a Python, so it's more prevalent. But that's
Mhm.
just during model training. There are a lot of other hoops that you have to do. For example, once your model is trained and then you want to make sure that the underlying matrix multiplications are optimized. So typically that is
Okay.
done through CUDA. But NVIDIA gives you tools like TensorRT and these other things that literally take your model compositional graph, and they do all of these things for you. So you do not, more often than not, you will not need to touch the kernels yourself.
Mhm.
When I say kernel, all it means is a function that is running on the CUDA, on the GPU, right? So you would not
So,
have to, but they have a C++ and these kind of things. But more often than not, you will not be doing a job where you will need to use C++ or something like that for your,
understood.
yeah.
So basically, training a model means it's like providing a data sets in the understandable manner. Is that right?
No, that's not. That is one
Okay.
thing, but training a model essentially means that imagine that you know that you think of from a real life, right? You have a lot of points. You want to fit a
Mm-hmm.
curve to it. Correct?
Okay.
You
Okay. Yeah.
maybe you have an idea it's a straight line, but you do not know what your M and C is, right? So let's say y is equal to
Mm-hmm.
mx plus. You have your x, but you do not know what your M and C is. So you want to
Right.
use your data to be able to find M and C, for example, for a straight line. But
Mm-hmm.
think about now, instead of this straight line, it is a very complex, very large equation, right? And now you want to find all these coefficients such that they explain your data well.
Mm-hmm.
I'm watering down a lot of things, but if you really want to build an intuition, think of it like very complex function fitting. It's functional approximation, to be honest. In fact, there is a theorem called universal approximation theorem, which it literally means you can take any function and you can approximate it using neural networks.
Understood. Sure. Thank you.
Yeah. Okay.
Yeah, I'm
We
good.
do.
Thank you.
No worries. Go ahead. Hello, Vidu? I can't hear you. Your hand is up.
Vidu, if you are here, you can ask your question. I have unmuted you.
Sorry, I accidentally pressed it.
Yep. Go ahead.
Sorry, I accidentally pressed it.
Okay. Nitin, you have any question that you wanted to ask? I'll allow Nitin to talk. Go ahead, Nitin. Yep.
Hi, can you hear me?
Yes, I can hear you. Go ahead.
Perfect. Yeah, my question is more around like using of or usage of this large trained models yeah in private workspace, right? So as I understand, all these models are kind of available in open setup, like you can use in public infrastructure like or any public cloud, but how to use them in private workspace. I'm asking that question because I'm coming from healthcare background, right, where you have like a lot of compliance and a lot of regulations. So
Correct.
you just can like import any model from open world and like use your own data to get some sort of outcome. So could you touch
Correct.
upon those and how it would
Sure.
work? Like even if we have to do some sort of POC or something like that?
Yeah. Yep. So definitely one thing is that I'm assuming that your data cannot leave you, for example, right? So in those cases,
Yes.
um,
Yeah.
there is no a problem in, like, for example, for medical imaging, right? You will need a model that is not technically just a text model because you want to process images, right? So let's say you were able to grab hold of some multimodal model, which also understands images really well. And then you took that, and then you will have to fine tune it on your own data, right? So the idea would be like, okay, you take that pre-trained model, take the weights, copy it on your own system. That is always allowed. And then you can fine tune it on your own data. So your data will never leave your system. And you do not have any, I would say, it's not imperative for you to release the model to the world, right? Because open source means you can take that particular image or the weights, and then you can fine tune it from on your own data for that. By the way, another thing that people have seen is that a lot of times for very specific use cases, let's say for medical imaging, where data is, let's say, not plentiful, where it's very likely that even in the internet scale data, the model might not have seen those kind of things. In that case, a lot of times pre-trained models are rendered kind of useless. In those scenarios, it's much better to just train a model from scratch on your own data, if possible. Or take a very lightweight model, right? And let's say resonate or something, and then do what you need to. So these things are definitely worth exploring. I hope
Okay.
that answers the
So
question.
yeah, so in that context, I mean, I can give you example of couple of use cases, right? So one is the medical imaging, right, which you mentioned. So for example, there is mammogram data, right, or the breast cancer data, like where you actually want to categorize patient into low, medium, and high risk category
Yep.
thing, right? Um, Definitely. I mean, I'm not sure if those kind of models are available outside. Um, and
Correct.
then how you actually, use any lightweight model and it can actually train within your private infrastructure and get the desired outcome.
So when you say your primary infrastructure, do you have access to cloud, like servers, or you have servers, right, with GPUs on them or not?
Yeah, I mean, private infrastructure mean like it's more like uh, it's its own private data center or something like that. It's not like I'm talking about the public cloud like AWS or maybe
Fair enough.
GCP or something. Yeah,
Fair enough. But so what I'm trying to say is you could always have nodes that are on-prem, in premise, and they have GPUs on them. So as long as
correct.
you have nodes with GPUs on them, you can do it. Yeah.
Okay.
Yep. It's just that these are like you will have to configure and set things like NVCC and NVIDIA compiler and all these things, right? And links and everything. But if that's why there will be an overhead when it comes to setting these nodes up. But once these nodes can talk to each other and GPUs within the node and across nodes can talk to each other, then it doesn't matter whether it's on the cloud or on the prem. On the
Yeah.
you can, yeah. But you can
Yeah. So
totally see overhead to set this up. Yeah.
yeah, it looks like theoretically it's achievable, right? But how could I actually leverage this course to uh, do those kind of POC in a private workspace or private infrastructure?
So there are a bunch of models, and I think that literally can be also fine-tuned even on the own computer. Actually, Apple, there's a design style called SoC, silicon on chip, which essentially means that you can do compute on your own machine, or you can take Windows, for example, let's say. And I would, again, the question is, do you really think that you need a model of very large size to do your problem? Right? If you need, then there is no way you can do it on your own computer. But let's say you want, like, I do not really think that you need a very nifty model of like 500 billion parameters or 1 trillion parameters to do this MMG, right? My gut feeling says that you can really go very far with 1 billion model or something like that. If that be the case, then even one or two GPUs will be enough for you to be able to train it. You can literally train it on your own computer if you have NVIDIA on it, NVIDIA GPU on it, like let's say any Windows enabled machine or something.
Got it. Thank you.
Or if you have, yeah, I think. Anyway, I can come to some very specific use, company with specific things towards the end, if that's fine by you guys. Okay, I'll take one more question, and then I'll definitely give everyone a chance to ask questions towards the very end. Jamie, please go ahead, and then yeah,
Yeah, are you able to hear me?
yep.
I'm coming from an DevOps background, so mostly
Mm-hmm.
like looking for an to switch to the MLOps side of it. I have basically very basic understanding of ML as of now. So how tough would it be like it will be like to jump into this MLOps
I
and
will,
explore the areas?
I'll come to it when I come to the MLOps piece, but I totally will try. I'll answer this question for you. Okay.
Okay,
So I don't know how difficult might be dependent on our own competencies, but I'll tell you what that leap essentially means in general.
okay,
So if that makes
okay.
sense. Okay.
Hmm.
Cool. Matthew, yeah, go ahead and please go ahead and ask the question. Let me allow you to go ahead.
All right. Can you hear me?
Yeah, I can hear you. Please go ahead.
Okay. So I guess my question is somewhat related to the previous question. So I come from a background of in statistics and math, and I
Yeah.
have been working in the data science field.
Mm-hmm.
So I have the understanding level of the different statistical models, the machine learning models, on a theoretical and on a small data level.
Mm-hmm.
So to advance into AI and a real-time application,
Mm-hmm.
what kind of paths do you recommend? Like things I see, data preparation, things like that. I've been doing a lot of data manipulation, data science.
Okay,
Summarizing
Viva,
things like that.
I will tell you
Oh,
what. Can you write down a sentence? Hmm?
Mhm.
hello.
Home.
Yes.
Tell
Someone
write a
please.
sentence. Home.
Okay. Someone's
Sorry.
mic is on, please. Yeah, whoever is
Okay,
on
go then
speaking.
draw.
Hello. Let me. Who is speaking? Anyway, so I'll answer this question.
Yeah, car.
So typically when I say data preparation, right, in this case, I meant being able to do transformations of data on really internet scale. So you can totally see that straight away, just something that fits on your pandas into your pandas data frame will not work. Right. So this means like this entails, let's say, one level deeper, right? Okay, maybe I need to understand Spark. Maybe I need to understand some way of doing streaming data processing. One example. Training, for example, right, will become differentiated. How? So now, for example, when you're doing a smaller model, right, you are able to train, let's say, an ML model, or let's say a deep learning model that is not too big on your own computer, right? You do not need GPU for example. But now,
Mhm.
right, though your models don't fit on a single computer, models don't fit on a single GPU, on a single node. This means you need to understand how different mechanisms through which distributed training happens. Not just that, if you are really being quizzed, so let's say if you are interviewed for Amazon, for example, or let's say NVIDIA or someone, right? Or they might even ask you, okay, tell me, like, how does this happen? So in the API world, you could literally just look up API and do it, right? But typically interviews will entail you to understand deeper things. So of course, being able to do something is good, right? Being able to read an API and get it done is really good. But in general, what happens is that people want deeper understanding. So in your interviews, someone can ask you, okay, tell me how distributed training is accomplished. And now there could be many tweaks to it. Let's say the model is able to fit on a single GPU, but the data is tremendously big. Then what kind of paradigm do you follow? So answer to that is, for example, data parallelism. So we cover these kind of things in our models, right? So training becomes differentiator. So think about whatever you know and make the data very big and make the model extremely big. And then those are the new skills that you need to pick up compared to, let's say, and even when it comes to, for example, if you have math and stats background, it's very good. But still, for example, if I asked you any uh, explain me direct preference optimization, or tell me how KL divergence was used in Instruct GPT, the paper, that RLHF component, right? So your background will be very useful when you blow through papers, right? So it's of course it's very important. So if you have a
Okay.
math and stats background, it's very useful. For the people who do not have that background, what we do is we also have probability and statistics course where we do teach scale development. Of course, probably literally will take like 5 months to complete, 3 months to complete on its own, but we give you enough intuition, enough math for you to be able to read papers. In fact, the hook there is that we show some mathematical expression and we want you to be able to understand, have the tools to understand, at the very least, RLHF paper, for example. Right? So let me take this chance. You guys can see my screen, right? So let me just quickly show you one thing. Like, for example, and why we do this way is, let's say if you look instruct GPT, right? And let's say, where is this? I don't know why. 1 second. So we have this here. Is this the one paper? I think so. Yeah. So for this famous paper, right? This is the paper that literally. So if you flow through this paper towards the end, you will see these different math expressions. Right. So let me just do. So if you do this piece, right, you will see some E, which is expectation, where X and Y are like stuff like this, right? So we really work hard to explain these things to you, like have the necessary math background to be able to understand this. Because once you understand this, you will do well in your interviews. Otherwise, right, like from my experience, because when I conduct interviews or anyone, I have seen that a lot of times people try to like really understand whether you have a cursory knowledge of something or a deeper understanding of something. Yeah. And also from compared to traditional ML experience, you never had to think a lot about how much time it is taking for a single answer to come back from the model, right? During your prediction. But right now, in these cases, one single prediction reducing the time it takes to come back with an answer from the model, it becomes a proper problem that people spend, like literally you could have a career in just this inference optimization, for example. Okay, I hope that answers your question. Okay, there looks like Naveed. Okay, guys, what we'll do is I'll take 2 more questions, or maybe whatever hands are up, and then after that I'll just go ahead and then I'll address questions towards the end. But there will be certain sections I feel which will preemptively answer a lot of your questions anyway. Go ahead, Naveed.
Yes, hi. Is this program focused on language models, or are there also some curriculum for computer vision?
There are proper programs for lessons for computer vision. In fact, we also cover so generative AI is not just for text to text. It could also be from, let's say, text to image, image to text. So we also cover multimodal modeling or multimodal generative models. We also cover, for example, diffusion. Yeah, so I teach a
Yes.
course, for example,
So-
on diffusion, where you probably will be able to understand things like how does a text transform into, let's say, an image.
Yeah.
Right, for
So
stuff like that.
do we get
Yeah.
get to see what's in the curriculum somewhere, like the
I think
syllabus of the program?
I feel that I'm not the best person to answer that. I'm an instructor, but I'm sure that
So
maybe people from IK operations and everyone could be useful there.
So,
So
Javed,
Okay.
I'll ask the program advisor to call you after this session.
Okay.
The program advisor will share the curriculum with you and walk you through the whole process. Okay?
Okay. Sounds good. Thank you.
Thank you.
okay, let me. Yep. Okay. One more question I will take. Jay. Okay, go ahead, Jay. Go ahead, Jay.
Hi, I'm an undergrad student at Ohio State. I'm doing CSC right now. I had 2 questions actually. One was, what exactly do you think from like my point in time that would benefit me a lot to get into AI? I'm doing a stats minor as well.
Okay.
I will definitely be specializing in AI in my senior year, but I wanted to work on some projects or something in that field, in the AI field, like work on my own AI model or something. But I
Sure.
just didn't know how to get started on that. I wanted to know if you had any advice for the same.
Sure. Yeah. So first of all, I'll definitely say that, like intellectually in itself, AI is a very interesting field. All of you guys, I'll definitely, everyone will be served well if they are not just guided by, let's say, something is fashionable or something has money in it. It is very exciting also. So I feel that, from day one thing everyone should do is, try to decouple yourself too much from like, oh, it has great career prospects. Yes, that is true, but that's not the only reason you should do it, because then everyone will be doing it with the same kind of passion because they want to earn more, and then you will be lag at some point. No. I'm just saying generally before prefacing my answer for you, Jay. And
Yeah.
for you, Jay, I would say that first of all, take a smattering of very good theoretical courses, right? Where typically these courses is also will also have a lot of good lessons, like assignments and everything. Dutifully complete them. That's the number one thing. The second thing is that I think once you start have a better understanding, you will understand what are the open problems. So pick hard and important problems, right? So that will guide your research. So if you take a very hard problem that is not important, then like it will not gain enough traction, like even from a participation perspective. But
Yeah.
if you take an important problem that is hard also, so that is where you should do your research. So remember
Okay.
those two words, hard and important. And I feel that there are open problems that are still there, like many problems, right? So typically a lot of people, what they do is they do iterative improvement. An example could be, okay, people were using Relu, now I'm using Jelu, right? People were using Jelu, I'm using Celu, right? For example, multiple activation functions that they are. Okay, that's a great achievement, but have you moved the needle in terms of like, okay, this is literally an inflection point, right? So and which is very hard, by the way. Not every researcher
Okay.
will hit across an inflection point, but what I'm trying to say is that think about in whichever field you pick, which problems are interesting and they do not have a very nice answer, and is that problem really important? So I feel that responsible AI is very hot right now. Like how can you make your model not have biases? um of course, I'm thinking about improvements on having a larger context length, right? So that your prompt will be very large, stuff like that, right? So I feel
Okay.
that once you gain knowledge, you will have a better understanding of what problems are important and what should I pick. And that is where you should also
Yeah.
involve talking to your advisor about how you are thinking about this. And feel free to, like, of course, reach out to IK or me or someone. Like, no, we do provide, like, by the way, we also have a lot of these mentoring sessions as a part of IK. So we conduct interviews, right? Let's say before any of your important days, right? You could schedule a coding interview or an AI interview, blah, blah, blah. But also we have tutoring sessions where a lot of times we find ourselves giving advice around these kind of things. So, those are some of the good plus points for sure. I feel. Yeah.
Okay. Yeah. I'm actually writing a paper about how AI, the bias in AI is like pretty bad
It's
in
very
my
important.
philosophy class. It's
So
extremely
two things.
important and
It's very
yeah.
important. And again, the question is, right, a lot of times people just say it's bad, right? It's biased. But again, there are two
Yes.
questions. One thing is, how will you measure bias? So three things.
Yes.
First of all, how can you quantify how much bias there is? So for that, okay, how will you create a data set? How will you measure? Second thing is root causing that bias. Where is the bias coming from? And the third is how mitigating that bias. Now, in any of these verticals, you could have good papers, right? So
Yeah.
what I'm trying to say is, if you start thinking from first principles, then it helps in general in careers, in academic career as well. I feel that when people just say, oh, it has bias, but then understanding, okay, how will I know how much bias there is? Where is the bias is coming from? And then
Yeah.
again, having a better differentiated view of bias. Okay, in these areas it is biased, in these areas it's not biased, right? So you can slice and dice the same problem from many angles. And then
Okay.
like, yeah, so think about like when you start like also thinking through, like developing your first principles thinking, every one of you. Okay. Okay, I'll
Thank you.
Garima has a question. Yeah, no problem. Garima, go ahead.
Parivesh, I think in the interest of time, we can take rest of the question after
Okay,
we are done with the slides. Hope that is
fair
okay.
enough. Yeah, I think that makes sense. Garim, anyone who has their hand up, please, I'll address your questions once I come to the end. Okay, so please do not
And
feel offended.
just to add to what Parivesh has been talking about, so guys, I know you are trying to get your queries solved in this session. Just wanted to add that as part of the Gen AI and MLOps course, which IK is offering, you will get 5 such mentoring sessions. So you will get one-on-one time with leaders like Parivesh, where you can ask these questions in details and get it answered. Okay, Parivesh, over to you.
Yep, thank you. Yeah, of course, today, not all our questions can be answered, and if we will not have all answers today, but certainly, our idea is to just throw light some aspects of our program as well as in general. So no matter what, you walk away with some good knowledge. Okay, let me come to the next one. And so now a little bit of understanding about, like, for example, in the MLOps world. So MLOps world, right? Like, think about, there are many aspects to it. So for example, one part is, and this is not exhaustive, one part is, for example, data versioning. So let's say, right, as a scientist, you produce a model, right? You must have used some data, some data to train your model on. You must have used some architecture. After that, let's say you have some artifacts that you want to deploy. Now, before doing that, right, maybe someone might want to cross-validate and say, you know what, I also want to reproduce that model. Give me what model you used and what data you used. This means there should be a way for me to be able to do some versioning, right? So that someone else can reproduce the results. So building mechanisms for example, doing data versioning, right? Let's say, right, someone's model versioning, for example. Let's say you built a really interesting model. You did A/B testing, everything looks fine. You made it made it live, and now you're seeing, oh my God, like some KPI is going down. So I need to roll back. Now, question is, oh, how can you roll back to an older model if you have not versioned it? Like, is there a way I can have a record of these model artifacts where I can easily roll back to? Meaning I can reproduce any model anytime, and I need to remember a lot of model artifacts so that I can roll back or whatever, right? These kind of, so model versioning is needed. So a lot of like discipline is needed around reproducibility. Then there could be a use case where, let's say, for example, your model is out in the wild, and the only way, you can't ask your customers, oh, is my model good? A lot of times you have to infer from customers' behavior whether a model is good or not. For example, when Google changes search, like, you give a query term. Let's say you're always hitting you're going to the first page's last result. That's a bad thing, for example. Versus, let's say you are always clicking on the top one or two results, right? So you can totally see that, it's very important for you to record where the person, like, which page it occurred on, where in that page it was, and then only you can derive your metrics to even understand how your model is doing, right? So this means there is a place for people who can write these loggers, right? Who can really write the infrastructure that can log things, for example, so that I can have some sort of a KPI that I can monitor, like, really actively, to understand how my live model is doing. And there are many other pieces. For example, another piece could be, okay, now I have a model. Let's say you built a model and now you want to deploy it on the production machine. So you built your model on some UAT environment or something. Looks good. Things look good. Offline metrics look good. Let's say you now you want to deploy it. Deployment typically means that there should be everything there for the model to be able to take an input and give an answer. Meaning all dependencies should be there. The model should be on the machine. All of the things that need to be there should be there, right? This means, how do we make sure that this environment is there for the model to run? How do we make sure that those artifacts are there? This means there is a way we should be able to containerize certain things. And then the question is, okay, imagine that now, because we go out in the wild and people are giving, like, left, right, and center requests are coming. This means I should, like any traditional service, I should be able to scale up. So then the question is, okay, then how do I scale up in the model in a cloud native world, for example? Let's say Kubernetes is one tool, right? So containers orchestration, right? The only thing that changes is, for example, now instead of proper server code, you have a model. So model code becomes your model prediction becomes your server answer, so to speak, right? There are various other things. For example, you have to make sure that data is right, data is not dirty, has come from good sources. So this, you might need to know where the data has come from. So a lot of things like that. So there are a lot of bells and whistles around MLOps, but you can totally see this discipline is very important for us to be able to, like, really do things in a structured manner. Right. So, like, for example, let's say you want to have a lot of labeled data from your people from some other company, and you want to send them labeling guidelines, right? So MLOps will work with scientists to come up with, like, some sort of, like, labeling guidelines, how to label things, how to make sure that when the results come back, you have a very high quality training data, right? So you can see that there is a time like a lot of things can be done from an ML ops angle. So to someone's point, like yes, if you know Docker, if you know Kubernetes, the only thing you need to understand now is that how do these things change when instead of like a pod having pod, which is a Kubernetes term, instead of like a lesser service running a regular code versus a service actually being a model itself, what changes? Let's say now your system is like four models talking to each other. What changes? Stuff like that, right? So you can totally see that MLOps is a very key piece here. And we do have very dedicated, very dedicated courses and personnel who really have you go through, and it's very well thought out, this curriculum, in my personal opinion, because yeah, I have gone through it, vetted it and all. So I can totally vouch for it. It's very good. Anyway, and then, so now to someone's question, right? Like, who is attending this party, right? So this looks like there's a feast in town and there are a bunch of people, right? So looks like, of course, you will hear terms like ML engineers, you'll hear terms like applied scientists, research scientists. You will need, like, I've probably forgotten, maybe a data scientist for you can throw in. Compiler engineers, data engineers might also have a role to play. Product managers, engineering managers, and a multitude, right? So looks like there is a way in which all of these people could directly or in some way like enable someone to someone to be able to integrate AI into the products. Now, very quickly, I'll run through some of these so that you guys have a better understanding. So, for example, an ML engineer will be more often than not, depends again. So, if you work at a startup, right, a lot of times a scientist might have to do the heavy lifting from many angles, including ML engineering. So, what does ML engineer do? All that ML engineer does is given a model, he makes it possible to be deployed in the real world. Now, if that means, okay, how do I reduce the size of the memory footprint of my model? How do I make sure that the model is deployed on the right kind of nodes with the right kind of GPUs? How do I make sure that, let's say I'm throwing a few buzzwords here, but those are important. Like, for example, how do I do distillation? How do I do something called quantization, kernel optimization? There are many things that ML engineers can actually do. And the things that you have to do might change from one model to another. So this definitely ML engines will benefit a lot from, first of all, understanding deep learning and understanding these models. But they will also need to have a good understanding by and large about where the shoe pinches, right? So when I go to do training, what kind of bottlenecks I might run into and what are the current state of the art solutions there, and are there any implementations? Likewise, when I'm thinking about optimization, better inferencing, what kind of things are out there that make sure that ensure that my inference is much better than, let's say, a naive implementation of inferencing. Applied scientists and research scientists are kind of the same role. The only difference being that a lot of times applied scientists are mandated to ensure they are to ensure that their AI is being used actually in the real world. So they will publish, but they will not always have a big mandate to just publish. Their more important thing is like, okay, you do good research, but make sure that your research is used and in the real world, right? Research scientists will do science from, guys, I'm probably not monitoring the Q&A actively, but I will come to them. So please bear with me, okay? Research scientists will probably have a bigger mandate to push the frontiers of theoretically. But I am seeing a lot of times applied scientists and research scientists, the distinction is blurring, right? So very likely people will not have the bandwidth, companies will not have the bandwidth and infinite purse to say, just do research with no end in sight, right? So I'm seeing that a lot of times research scientists are being coded to become applied scientists, or at least without the title change behave as one. Compiler engineers, for example, right? They will think about, let's say, given a model, and let's say given which machine I'm going to do inference on, what can I do to make sure that inferencing is very optimal? What can I do, right? So that might mean, okay, there are a bunch of kernel optimizations that they might do, right? They might say, okay, you know what, this particular function that is running on the GPU is not well written. It has a lot of input output kind of latencies that it has gathered because it is reading from, let's say, global memory versus shared memory. Then how can I do something to make sure that that doesn't happen? An example of this might be traditional self-attention was order n square, where n is, let's say, sequence length of your prompt, number of tokens in your prompt. But someone wrote a faster implementation of that called flash attention. And flash attention essentially was all about making sure that the kernel, the underlying function that is run on the GPU is more optimized when it comes to reading from memory that is slower, right? So a back and forth reading, it kind of reduced. So stuff like that you might be needed. So you can think about things like XLA, CUDA, and these kind of things that will be very useful in these profiles. Data engineers, of course, right, a lot of batch computation if you need to do. Let's say you have data, you want to run some functions to deduplicate or do some transformation and all. So Spark and these kind of things will be very useful. So the ability to run really big like functions on very large data sets or on streams, useful. Yeah, I'm seeing all the questions. I'll come to it. I'm seeing there are a lot of like questions that are coming. I'll make sure that I'll address them, I promise. Then product managers. So of course, product managers, first of all, product managers need to make sure that the product is catering to the customer's needs, right? That will not change at all. The only thing that will change is, okay, customer has a need. A customer had a problem that we were solving through, let's say, using a technique that could be done better if we use AI. Right. So as a product manager, all you need to probably think about is, okay, what of the existing things that you are solving, for example, right? What things can be done better through AI, if at all, right? Maybe AI is not a silver wand. It will probably not be the best solution for many use cases. But for whichever use cases you think AI can do better, product managers can like try to be ambitious and galvanize a team to do that. That's number one thing. You could have existing, and then you could have also build features that are completely new that nobody could even think about. And now AI could be a use case for that. An example I gave was, let's say, writing product descriptions using generative AI. So give an image of the product and you can automate writing product titles that are more compelling. Right. So think about any new features you can add using AI. That's one way to think about it. And the second way to think about it is, okay, of the existing solutions, which solutions can be done better through AI? And of course, as a product manager, you will need to understand, if you understand, okay, in this team, I will have engineers, I will have scientists, I will have, and a lot of times scientists and engineers will get a little, like caught up in the intellectual battles they are having with the model and whatnot, right? But maybe, you be a truth sayer, so to speak, and who can contextualize, okay, why we are doing something, right? To bring people, make sure that people are not distracted and, like going in the right direction and all, right? So understand every particular detail about like making something go out in the wild, and understand where we are missing, where the scientists might be missing something, right? Because I think product managers will also bring a little bit of domain knowledge into the picture to really evaluate how the model might do, right? So understanding, okay, how will we know whether the model is good or not? Whether this particular feature that I built for the product, is it really doing what it should? Forget about what model it is, right? But whether qualitatively is the model results, are they good or not? Do they make sense or not from a business angle? And engineering managers, as you can totally see, right? So let's say if you are an AI guy and let's say you became an AI manager, then of course you need to understand, okay, I have now some workload where I need to make sure that some product has some AI component and that needs to be productionized. So what kind of people I need to have in my team, right? So maybe I need to hire an ML engineer. Maybe I'll have to understand, for example, how the workload of a traditional software engineer can be put in Jira versus, let's say, how we should calibrate ML engineers or apply scientists' work, right? A lot of times, work of scientists is like, has a loop. It's not a DAG technically. So meaning that, like in programming, if you can go from point A to point B, but a lot of times, but in science, you can have like a point, oh, you thought you went ahead, but then you found an error, you have to go back to school, like, drawing board. So understanding those nuances. Anyway, okay, that brings me to the end of it. I kept it short because I had so much to think, but I'll definitely try to like quickly pour over some of the questions. I have a bunch of questions. So what I'll do is I think I saw someone who had who was it? Okay. So whoever has questions now, I'm willing to like answer a few questions here and there. So and I'll also go through. Okay, Suresh, go ahead. Anyone else, please feel free to raise your hands. Go ahead, Suresh. Hello? Hello? Suresh, can you hear me? Okay, then I'll move on to the next person till the time you're figuring it out. Garima, I saw that you had a raised hand before. Do you wanna? Okay, let me unmute
Hey,
you. Go ahead.
hi. Yes. Thank you so much. Firstly, very informative session. For me, I mean, the company I work at, we are at a place where we are getting all of this legalized, right? Because of security data and everything. Where feel like I want to know if we will cover like via AWS, we'll be able to connect to open AI and open source like data. Will we be covering those kind of things also in the workshop?
We try not to be very married to like a given platform, but I think we use AWS. We do not like setting up things like or how will we talk to OpenAI through, because we do not give you an OpenAI license. Someone might be not be able to buy it, right? So, but typically, I know for a fact that AWS has, for example, SageMaker, where they host their own models, not OpenAI, but certainly, I'm sure that you can set AWS to have one-way, like two-way connection, right? Like that is totally possible using NAT gateway and all these kind of things, where your architecture can talk to the internet through an API call and get an answer back from the internet. It's totally possible to do it.
Got it. That's very
Nothing
informative
changes.
because currently we are using like Neptune from AWS SageMaker. So I'll definitely explore that route. Yeah.
Yeah,
Thank you so
SageMaker have a
much.
lot. SageMaker has a lot of models. I'm not sure if, because OpenAI never releases its own model. What SageMaker does is whatever models weights are already initialized. For example, Llama 2, Cloud, all of that you will find. Those are also very good, by the way. But I will not like claim that they are as good as Gemini. But you can totally see, right? Like OpenAI and Gemini want to earn through API calls. You do not have a lot of handle in terms of how do I tweak this model, right? The answer is what you get is what you get. It might be very good, right? But what I'm saying is, please understand the difference between both those things. Yeah,
Got it. Sure. Thank you.
no worries. Um, Anyone? Let's see. Let me quickly take a few. I see a raised hand. I'll come to it. Um, Someone else has a raised hand. I see three people with raised hand. I don't know why I'm not seeing that. Let's see who else. I see one person. Okay, Nitin, I'll give you a chance. Please go ahead and ask the question, and then yeah,
Sure. Can you hear me?
yep. Please go ahead.
Yeah, a couple of questions. So, what kind of capstone projects this course would offer? Like, what kind of Gen AI application,
Sure.
developing?
Sure. First of all, corresponding to every, like for example, computer vision and everything, we have like assignments, we have projects. That's one thing. We have capstones, right? So for generative AI, I can talk about like the assignments that we set. For example, one of the problems might like one of the problem could be okay, like um, build a toxicity detector using what you have learned, right? And we have use cases where for example, might give you a RAG based problem. So we have such kind of problems that we give. We are mindful, of course, that we do not we will not give you a problem which will entail like running training for months or fine tuning for months. So it might be on a smaller model, right? Maybe for a T5. So one other thing is that you do not need to learn all of this using like a very large models. The underlying principles do not change, right? We also, for example, might ask you to do DPO on something. We have a reinforcement learning course where we ask people to do RLHF on a preference data, for example. So yes, I can totally tell you that, we really believe not just in like, declarative learning, teaching, meaning that, we give you a set of things that you need to learn, but we typically, like you see this, you might get a sense of how much engagement we like, right? So we punctuate our learning through interaction, and we give you assignments. We have to do follow-up tutorials, and we have projects where a lot of times students also collaborate. So
Got it.
we have a Slack, we will have a Discord channels, for example, for a given batch where they can also discuss among themselves. I feel that collaborating learning among students also is very critical to learning. Yeah.
Yeah. And the second question I have is for Gen AI, like how much is ops there, like, in terms of implementing it at enterprise level? I also put that question in the chat box. Like, I'm just trying to understand, like, Gen AI has its own Gen AI ops component, or it's ML ops that actually takes care of it.
I think kind of all of those things are subsumed in it, right? So when we say ML ops, I think more often than not, there are certain bells, like certain really important things you need to understand from, let's say, inference perspective, right? So there are some optimizations that are only there for LLMs. Example being, for example, KV cache, flash attention, right? So some of those things that speed up inferencing are very bespoke to LLM world, right? That might not, like, let's say, be used for doing better on ResNet if you want to condense, let's say, a resonate to a smaller size. But distillation, there are some techniques that will work across the board. There are some things that are very, very particular to, let's say, the LLM world. But as you learn, gain knowledge, you will understand those things. Of course, yeah, like, so ops also, in my eyes, I do not see a big distinction. By and large, we want to teach such that LLM LLM will not, like, yeah, for example, RAG, you will like to understand RAG more, how to build indexes, vector databases more, and we have those pieces also. We do teach why RAG benefits, for example, from vector databases, right? And a little bit of ops around it. But I think we are more general, and it covers more often than not everything that LLM ops needs in general.
Okay,
Again,
thank you.
remember, right? Some of these challenges could be very company specific. It's very difficult to, let's say, teach a general framework through which you can bypass, or you can, like, set up LLM in your own workstation, in your own, let's say, work environment. That needs a lot of things, like what is allowed, what is not allowed, right? So, but I think our idea is not, our idea is to facilitate, to tell you everything that you, like, that you can learn, to understand, first of all, where to get started, what kind of questions to ask, what kind of questions to push for in your own work environment, right? Otherwise, if you don't know what to nudge, where to nudge, for what to nudge, right, then, we can only shoot in the dark, I feel. Yeah, I think that is what we should have as goals, as takeaways, is like, okay, I know now to get here, these are the things I need. Now let me see what I can get enabled easily versus where it can be a longer battle, all of these other kind of things. Yeah.
Okay. Parivesh,
Thank
while you go ahead answering the next question, I have an announcement for all the folks who are here with us. So for this particular workshop, we have some spot scholarship. We will be giving discount up to $1,500 for both MLOps course and generative AI course, but it will be for the first 5 enrollments. So if you are interested, the program advisors will be reaching out to you after the workshop. Please book your seat because this scholarship is on a limited basis. Parivesh, over to you.
Yeah, no problem. Yeah. How long is so some of these like length of the ITA program and all that, like, please, like, feel we have Utkarsh. He's the best person to answer those questions. Utkarsh, please, like, some people are asking how long is the program and all these kind of things. Can you just
Sure,
give
sure. I will answer them in the chat itself.
okay, so these will get answered. I'm only trying to answer questions around the curriculum and everything. So um thank you for whoever has written some appreciation. I really take it with like, with both hands. Suresh. Okay, does IK have a platform to do practical hands-on things like Databricks, Amazon Bedrock? I feel that, it's like the cost structure of that is kind of difficult to iron out. I do not think we do Bedrock and Databricks. We'll try to keep it like, okay, we give you a kind of EC2 and you can use like, Hugging Face and everything. We do not give you, like, if I'm pretty sure we do not give you Bedrock. But we do not stop you, let's say, from uploading something on your S3 and, like, on your machine and do things and all that. So Anand, yes, ML compilation is a very good area, but it's a very, I would say, like, a very competitive, very specialized area. So if you think that you have the chops, and if you feel that we will have to learn like quite a bit of CUDA and understand deep learning at a good level. I love CUDA, so I'll definitely add anyone who wants to do that. If you're willing to go through the grind and understand and enjoy the process, please go ahead, and ML compilation is a good area to go into. Yes. And it is not just that, it will also understand, like, you will need to understand a little bit of networking and, like, a little bit of OS to parallel programming, of course, those kind of things. But it's a fascinating area, pretty good, very specialized area. Yep. Jeffrey, in terms of instance optimization for inference, do you still try and distribute a model like Spark, or do you try and do whatever is possible? Okay, Jeffrey, no, we still could have models which are very, very big and do not fit on one GPU. In that case, there are techniques like tensor parallelism, sequence parallelism, stuff like that that we do to ensure that our inferencing can be done faster. We have things like KV cache. We could have a faster attention mechanism that we are using. There are other things like activation checkpointing. There are many, many, many things that that people have to do to make sure that inference. Then you have to do distillation. There's something called quantization aware training, which means essentially that okay, if you know that if your floats are getting multiplied, let's say if you're multiplying two floats that have many, many decimal points versus let's say two decimal points, three decimal points. So if you can quantize, meaning if you can approximate or round your weights and different decimals that appear, then you can really do things faster. And there are ways to make sure that that rounding doesn't lead to a lot of bad performance, right? So there is something called quantization aware training. If you do that during your training process, then you can do something like then you can benefit from it during your inferencing also. So there are many techniques that people have to generally understand about optimizing inference. Yes, someone asked, do you teach PyTorch? Yes, we do. In the frameworks, we do teach. We teach PyTorch, but we do not discourage people from learning TensorFlow. Up to you. We do not want to couple too much with one given framework. If you can get everything done through TensorFlow, please go ahead and do it. Sivanesh and Anand, I will take your questions. I'm just quickly pouring over some of the chat questions, and then I'll come to you guys, please. This is a beautiful question. How can we know if pre-trained model has the knowledge of my domain, such as Llama 2? So this typically will be done. So let's say you will need to have an evaluation data set from your own domain that you have curated in-house, where you know, okay, for this input, this should be my answer, right? And then you will need to take your model, like your pre-trained model, and for each of those inputs, emit an answer and compare what should be your answer versus the prediction. You need to come up with some metrics, right? So you need to be able to compare for every input the answer that you know should be there versus what the LLM gave out. And then you need to have some metrics, right? So this is a very good question. How to have understand whether the pre-trained model has good knowledge. So this means you need, for sure, you need to very high quality data set that you have curated in-house that you for which you know you have very reliable right answers. And typically you use humans and experts to make sure that this is there. Okay, very good question. Another question I'm seeing is, what's ask probably a question towards the end of the session. How should folks in solutions role? So a lot of people in solutions, typically what they have to do is that, like for example, if you wanted to do for NVIDIA or anyone, right? Like, or let's say you worked at GCP or SageMaker or something, right? Then a lot of times your clients will be people who want to use your offering to train their own models. They might run into some problem. They might come across something fancy and say, can we do this on using your platform? So a lot of times, or they can say, you know what, we have a model, we have a data, we have model, but how can we optimally train it without incurring a lot of computational cost? So you might need to know everything to be able to have a very educated discussion with them, so much so that you might also need make their life easy, right? Tell them about something. For example, let's say if you worked at NVIDIA and someone wanted to do a lot of LLM, could you tell them about TensorRT LLM? Could you tell them about Nemo? Stuff like that. Or if they were working with, let's say, like recommendation engine, could you tell them about Merlin? Right. So as a solutions person, you to be able to understand what pieces to talk about, where their pain points are, and come back to the drawing board, and within your company discuss who is the right person, what should we say, and quickly let's say do a POC and show value and all these things, right? So in those areas, solutions architects could be useful. AI solution architects. Okay, we do not teach prompt design per se, to be honest, but we teach why prompting works. So we do teach in context learning, and we do teach why in context learning works in general. But we do not, and we teach, for example, prefix tuning, p-tuning, and these things, but we do not necessarily teach you to become, let's say, a prompt engineer, so to speak. right? But we do teach you, like, what kind of inputs, for example, what is instruction fine tuning and these kind of things. So I personally feel that there are more opportunities in training models. Prompt designs, yes, for let's say people who are doing OpenAI API calls, yes, maybe their prompting is very important. But wherever you think that prompting is not the only thing that will take you far, and you have use cases where you want to train your own model, then you need to have such. How do you teach distributed training on GPU? So we have like we take a small model and, like, we teach you how to do data parallelism. We do not teach you every single kind of parallelism, but things can change. What are it's valuable new grad? Yeah, some of these questions you can definitely ask, like, like in your Utkars is going to answer this question live. So maybe Utkars is the best person to answer that question. Minimal industry experience, what kind of projects do you believe are most valuable to showcase? So for an early AI ML role, I would definitely say, like, learn a lot of like proper theory. And I would definitely say that if you learn enough theory and really practice programming also, if you combine those two things, and do preparation, then when you get a call, you will be very valuable. And when you are studying, maybe like, maybe you could just do a few projects here and there, go to Hugging Face, take these famous, like, for example, PEFT and these kind of, like, take a few models, run Google Colab notebooks end to end, understand what is happening, right? So some of those things you could do. Um, Again, these kind of questions are, how long does it take to train a model? The topic is completely new, right? Depends on how big the model is, right? But if you do something called LoRa, load rank adaptation, or you do something called use adapters, this could be learned very quickly. So there are ways to fine tune a model very quickly. Now it's called parameter efficient fine tuning. So there are techniques that are there to learn this very fast. Joseph, I just had a very frustrating session with ChatGPT. I'm finding it very unpredictable, and the problem is occult and appears to be political rather than technical. How can one base a career or a business on the shifting dunes? Yes. So, like I said, right, like understanding, like, these models will never be perfect, and these models can have very inexplicable behaviors. Understanding why that might be happening, how to find ways around it, uh, how to align them better. All of these are very valuable skills. But again, you're totally right. Like, these models can totally hallucinate. But then the question is, like, how many things you can automate while, like, doing badly on few things here and there, right? So it's always a trade-off. And the idea is to get better and better over time. Okay, I feel that by and large, and I will just answer. Anand, you have a question? Sorry, I will unmute. Go ahead, Anand. I just unmuted you.
Oh, yeah. Yeah. Uh, Thank you. This is just a follow-up question for the ML compilation question I asked before. So,
Yeah,
coming from a semiconductor background with the knowledge of chip architecture, how does this position for the ML compilation role? You talked about deep learning knowledge and all that, networking, parallel
correct.
programming, CUDA. But chip architecture knowledge I have more of that than any of the other things. So, how does that position?
Sure. It really positions you well in terms of, for example, um, if you wanted to do, let's say, a float 32 operation versus, let's say, an operation that can be done on the GPU, but it's, let's say, less involves less significant digits, so it can be faster. What kind of within GPU, what kind of within GPU and communication patterns, access patterns are more important, right? Like, how stuff like that. I feel these are very important things, and compiler engineers are really useful. Is really good in making sure that the underlying calculations, right, are taking full advantage of hardware, and making sure that a lot of communication overhead is not there, copying data from, let's say, a global memory to shared memory within the GPU and all these kind of things. And you will probably need to, like, learn a little bit about, for example, NV links and these kind of tech, like, how do, for example, in distributed training, a lot of times there is something called an all reduced operation, right? For that, different GPUs have to talk to each other. These GPUs could be situated on different nodes. So then
Yeah.
understanding, right, for example, what kind of, let's say, a new Hopper H100 came, right? So if you're able to, let's say, understand these pages, and accordingly, for example, if you just wrote H100, and you went here, and if you're oh, not this, my bad, sorry. Where do I write? Right. So if you, let's say, you read like, everything about what is new in the H100 space, right? What is the new thing, right? If you could understand these pieces, and then you can look up like their job offers, and like, maybe look up, okay, what kind of compile. So if you look at compile engineers job profile, right? So let's see, LinkedIn. Let's do this. Oh, this is another art that will. So for example, if you wrote, I have a friend who is a compile engineer. Uh, there's a group called let's see, jobs, right? So how do I hide this? Oh man, sorry. Don't wanna. Anyway, sorry guys if you see anything that you shouldn't see. Let's see. Mm, mm, mm. So for example, if you, this is quantum, this is, for example, if you read Waymo job, right? So typically what will happen is, remember, these kind of things need a lot of things on Tesla or Waymo, right? A lot of inferencing needs to run on the chip, because you do not want to incur latency by, let's say, you see an image in front of you, you do not have the time to send your data to the cloud where your model resides. This means inferencing needs to happen on device. In those scenarios, right, you have a lot of use cases for writing custom chips, custom, like build custom chips that can really do well on the device.
Yeah.
Right. So you will have such kind of things, right? So if you look at what kind of things are needed, you will see that, for example, right, neural networks, you need to understand there are some compilers that are really specific for neural networks. So you can know about that. In general, understanding where, like, machine learning is very important. But I have seen mostly C++, CUDA, these kind of things are useful. You do not have, and then understanding communication patterns and all that. And so typically, like these kind of, like, for example, if you went to work at AMD, right, they will ask you to know, for example, things like any GPU related like, compiler backends, right? So for example, CUDA or, well, like, these kind of things, and stuff like that, right? So, and then understanding, like, any of these, this is large language, or like, models and all these kind of things, right? So video models and all that. So I have never seen anything where you do not have to optimize, let's say, a GPU kernel. If you have to have an optimized GPU kernel, you need to understand, for example, a lot of things like access patterns within the, how is the code really doing something suboptimal and how to optimize it. Stuff like that.
Okay. Sure.
Okay.
So this is a good career focus with a good outlook, right? Because next decade or so, there should be a lot of innovation, a lot of work
I
in this area.
personally feel it's a lot of interesting things to be done in this space. Yes, I totally agree with
Yeah.
you. Yep.
Thank you.
Let me, no worries. Yes, won't these companies expect a prior experience? They might, but again, that is why I think we should learn the art of how to pivot. So we'll definitely, like, give you enough to be able to, like, make that judgment call whether I should do a 180-degree change, or how should I take a long-term view and get there, right? So when the interview comes, I should be well placed. But while you are reading, while you are going through the program, maybe one advice could be, okay, can you take more AI related projects in your current work? Stuff like that, right? So there's a way to pivot. And I think that those kind of insights start coming once you understand the field better, because nobody knows us better than we do ourselves. And if we take help, then that clarity becomes better and better over time. Anand, your hand is up for before, right? Do not have any other question, correct? I think I by and large answered most of the questions.
I think Parivesh, Nikita raised her hand for a long time. Nikita, if you are there, please ask your question.
Yeah. So I think I answered. I don't see any raised hands, but if there's anyone who couldn't, I couldn't answer, I please feel free to have asked the question. I did not have that intent not to answer. It's hard to context switch.
Yeah.
Yep.
Hey, Parivesh, how are you doing?
Doing well, yeah.
So my question to you is like, what industry-specific MLOps projects you guys will be going through in workshops?
I feel that if I remember correctly, and by the way, these change from like, year to year.
Uh-huh.
This time I think we have 4 or 5 different kind of lessons where we teach different things. Like for example, distributed training, Kubernetes, Docker. We might not necessarily always, let's say for example, explaining Docker, explain, okay, you need to containerize a model. We might, because if your objective is to just learn containerization for a model, doesn't need to be a very large model. It could be a simple deep learning model also, right? So
Yeah,
we
but
have
okay. Okay, go on.
so if I remember correctly, the thing that we take one problem and then we use it for that
Mhm.
ML ops thing across the board, and we give separate things to do on for each of those parts. So in one part we might ask you to containerize the model. In another case I ask you to scale it up, stuff like that. And I think if my memory serves me right, it was a computer vision model. But these things change, so I do not quote me on it. We do keep these things dynamic. Yeah,
Okay. So it will cover from the start, right? The pipelines, starting from scratch, the data ingestion to the last step, model deployment.
correct. That is the intention.
Okay.
Yes.
Okay.
Yeah.
Okay, cool. Thank you.
Anybody else? Yeah, Krishna, any of those questions, I'm sure Utkarsh is the best person to answer.
So for these questions, Parivesh, let me take 2 minutes.
Yeah, go ahead.
Uh, So if you have, guys, if you have any profile related question that you want to transition to a particular job and this is your profile, what is the best program for you? So I'll suggest reaching out to your program advisor. What the program advisor do, they take your resume, they take your LinkedIn profile, connect with the SME, and the SME tells what is the right fit for you in terms of program and also how can you transition, how your transition will look like for AI ML jobs. So I think these questions, I'll not be able to do justice to these transition related questions without looking at your profile. So when the program advisors are reaching out to you, please connect with them, share your profile with them, and they will be guiding you in choosing the right program and telling you how the transition will look like.
Correct. And I think in general advice that a lot of people reach out to me anyway, outside of IK also. And my advice is always like, our direction change should be organic, seamless, and forward. Meaning that, do not try to. I personally feel that with the right guidance, right learning, the direction change is very organic. And our idea should be how can I gain that clarity myself through learning and through asking, using channels that Utkarsh is talking about. And you do that over a sufficient amount of time, and I think you can pivot. And yeah, as long as we pitch our expectations properly, we do justice to, we ask ourselves good questions, we do honest appraisal of ourselves, and we keep going forward. I think that day comes sooner or later. Yeah.
Thanks, Parivesh, for saying it out loud. So, for any, what we have observed is the transition is always organic, as Parivesh said. You cannot transition to any role with 2 months of effort. It takes time and patience. We are there to help you out in the journey, but it will be organic.
Yeah, I feel that, in general, that is how transitions should happen anyway. Because otherwise, you will probably cram up a lot of things. You will do well in interviews, but when you go to do a job, you will probably have a lot of imposter syndrome. You will feel a little nervous. I feel that, if you play that up, if you remove distractions, if you really stay patient, if you maximally utilize all the resources at your disposal, and you do not waste your time, you study, like I feel that, doing all of that, you will be at a better place. You will have more knowledge, more clarity, all of these things from an AI perspective, ML perspective, and very likely it will also end up in a very good result for you. Yeah, that's what I think. Yeah.
Okay. Parvesh, I think we don't see any more questions. Uh,
Okay.
First of all, thank you for taking the time out and patiently answering all the questions. I think we have taken close to 70, 80 questions so far. So thanks a lot for your time. We really appreciate it. Coming to all the people who are with us, please reach out to your program advisor in case you have any more questions, and we are happy to help you in your journey. Thank you and have a great day.
Thank you. Thank you, everyone. Bye.